proportional and non-proportional relationships, okay? Proportional and non-proportional relationships. And I'm expecting people to write down stuff. I don't want you to have your hands folded and looking at me. I'm not a comedian, I'm a teacher. So write down what I'm saying. So, why is this important, right? It's very important because you use it in life constantly. They use it in almost every field, right? So here, first we need to know what a definition is, right? What is a proportional relationship? When two quantities are proportional, that means that they have a constant rate or ratio. Two quantities that are proportional have a constant rate or ratio. What does that mean? Now, let's say I want to compare LeBron James' mid-range and Kobe Bryant's mid-range. Rest in peace, Kobe, right? So, if I look at LeBron James, a mid-range shot, for those that play basketball, is a shot that is beyond the three-point line, right? That's a mid-range because you're shooting from the perimeter, but it's a mid-range shot because it's not behind the arc, right? So, LeBron James shot, let's say in the first game, he made 10 out of 15 of his shot. In the second game, he made 20 out of 35 of his shot. And then in this last game, he made 5 out of 6, right? Okay. It's pretty, now if you look here, right, there's something that we're going to see in a second. Now, if you go back to Kobe, Kobe made 5 out of 7, 10 out of 14, and then 15 out of 21. So what do you see between these two guys here that is different? What do you see, yes?
It looks like LeBron shot more.
You say what? He shot more, right?
Yeah.
Oh, he shot more, all right? What else do you see here? Yeah. What else do you see?
The denominators are all different.
The denominators are different, all right? Good. What else do you see here? Yeah.
I guess that you could all multiply them by 7.
You can multiply all of them by 7?
Or something has 7 in them.
All right.
They're divisible by 7.
Okay. Which one is divisible by 7? All of them?
Yeah.
Okay, well, this one is not divisible by 7.
Oh,
this is not divisible by 7 either, right? Now,
3.
All right. Now, what I want you to think about when we do this is this. Two quantities are proportional if they have a constant rate or ratio, right? Now, look at Kobe here. He made what? 5 out of 7, right? 10 out of 14 and 15 out of 21, right?
That's proportional.
That's proportional. Why? Because he's what? Constant, right? He's shooting the same way every time. He's shooting the same rate because each one here, 5 out of 7 is the same as 10 out of 14 and is the same as 15 out of 21, right? So that means for every 7 shot that he takes, he makes 5 out of them. That's just constant. You want him on your team, right? Whereas LeBron James, he made 10 out of 15, then he went to 20 out of 35 and 5 out of 6. It's inconsistent, right? It's not constant. He's not shooting the same way every time. Because in the first game, he did 10 out of 15. Another game, he did 20 out of 35 and then 5 out of 6. Now, if you look at 5 out of 6 and 5 out of 7, you think this is better. But this is not consistent because these are not the same, right? The rates are not the same. You want someone that's consistent or you want someone that is inconsistent? Like he goes up and down, up and down. What would you rather have? Consistency or a lack of consistency? Consistency, right? Even though this looks like it's better, but it's not. Because he's shooting the same way, 5 out of 7, 10 out of 14, 15 out of 21. That means every time, if you were to simplify this, what's 10 out of 14 simplified? If you simplify 10 out of 14, 5, 7. What's 15 out of 21 simplified? 5, 7. See? So he's shooting the same way every time. So we call this a constant rate. Everything is the same. Nothing has changed here. Does that make sense? Right? This is constant. Meaning every time is the same thing. Right? And you guys that play basketball, that's what you want. You want to be consistent. You want to be constant. Like, in a good way. If you made 1 out of 7 shots, I don't want you shooting the ball. I do not want you shooting the ball, right? Because, yes, you're constant, but I don't want that. Right? Yes.
I'm constant of 0 over 0.
Why, do you play?
I can't play because of
I'm constant for about maybe 3 out of 20.
Woo!
I do not at this school.
3. Oh, well, okay. Well, nobody can see that. So how are you going to know?
In your imagination.
Right? Nobody can see that. So, all right. Now we're going to learn, right?
Actually, yeah, Gabriel, we just tell me it won't be 1, by the way.
Now listen to this.
Because we all want to.
We're gonna learn how to identify proportional relationships, right? We just did just now, right? Now, if you look at this relationship here, right? Coffee pound per and then cost, right? So 1 pound of coffee costs how much?
$3.
$3. 2 pounds cost 6. 3 costs 9. 4 costs. Is it consistent?
Yeah.
Is it constant? Yes, because 1/3, right? So determine whether the cost of coffee is proportional to the number of pounds. Is it proportional? Yes. Why? Because 1/3 is equal to what? 2/6, which is also equal to 3/9, which is also equal to 4/12. Because this is true and this is all equal to 1/3, we say that this is proportional because this is constant. All right, you have the same thing every time. 1/3 is equal to 2/6. It's also equal to 3/9. It's also equal to 4/12. This is constant. Therefore, the cost of coffee per pound is proportional. It's a proportional relationship, right? Now, what if you go to a store and they tell you this, which I've heard some girl told me, and she thought that she was actually giving me a good deal. She said, hey, listen, I walk into the store, right? And that day, they have what they call like a discount, right? And she said, if I buy anything over $25, I get 10% off, right? For $25, you get 10% off. And she said also, but look, she said, well, you can get more money off. She goes, if you buy 50, now you're gonna get 20% off. And she goes, if I was you, I would do 50. And I looked at her and said, it's the same rate. It's the same, it doesn't change. She said, no. She argued with me that day that it was better for me to spend 50 in order to get 20% off. Is she right?
No.
Because it's the same thing. But you see people that work in these stores, I don't know what they're talking about, right? So if 25 is 10%, 50 is 20, therefore 75 will be automatically what? Who knows? 30, right? And then $100 will be obviously what? 40%, right? So this is proportional because it's the same thing. Okay, the discount that you get is proportional to the money that you spend, right? So, but if she has said to me, oh, for $50, now you get 40 off. Now, and then for 75, you get, let's say she says 60 off. And then for 100, you get, let's say 50. Now, this is no longer proportional, right? Because the more money I spend now, the more money I will save. Yeah. Do you see this? This is not proportional because 25/10 is not the same as 50/40. It's a different thing. So the more you spend, the more money you save. Now this will be not constant. It's not proportional, but it's a better deal, right? So this is how you do this kind of stuff. Now, the next thing I want us to learn is I want us to learn to describe proportional relationship, right? So proportional relationship can be described in one way. For example, if I say to you that let's not use my age anymore because you guys have gotten too much fun out of that.
No, that's because you like to lie.
Right? And so I'm not going to talk about that anymore. By the way, my wife is still mad at you guys for hurting me. And if I call her now,
your idea.
she'll give
You
you
cannot blame us.
Okay, you know what?
To raise little children.
Hold on a second. Hold on. Hold on.
Said no.
Oh, you're lucky because I would have called her and have her talk to you guys, but we are still online. Anyway, and tell you all a piece of her mind, right? So, let's think about this.
Yeah.
Let's think about this here, right? So, let's say, all right, let me give the girls a little bit of a leeway here, right? I'll give you guys a little bit of a, so let's say that girls' IQ, right, is twice as high as boys' IQ.
Everything.
IQ, right? When it comes to certain things, right? So let's just say for the sake of certain things, you guys have a high IQ than we do.
Okay, math,
right?
listen to the sported.
Okay.
Bible,
Now,
listen to the sported.
now listen up.
Listen to the sported.
So basically, you can describe a proportional relationship using this, right? It's called, now, proportional relationship, they can be described using the form y equals to kx, where k is called the constant rate or ratio. It is also called the constant of proportionality, right? So I just made a general statement. I just say that girls' IQ is twice as high as boy's IQ, right? No matter what girl you pick, if I'm saying that this is constant, so this is proportional. That means if I take, for example, Alina, right, and I take Gabe, now based on my assertion, Alina's IQ is twice as high as Gabe. Based on what I say, but is this true? No, it's not. It's not. It is not.
Girls' minds develop.
IQ is
Wait, it starts with her. She got principles.
right. But you see here, what I did was look. What I did was I fixed this. I imposed this. But is this true? No. This is what I made. I made it proportional, right? I say that now. If I say now, I'm gonna change it. I say boy's strength, right? Boy physical strength. Let's call it BP. Boy physical strength (BPS) is 4 times as high as girls.
What?
Physical
It's not 4 times as high.
right?
It's not. We look at it like okay.
So which means that if
So they're not 4 times as strong. They are genuinely stronger than girls because guys just like
I'm fine.
yeah.
but they're not 4 times as strong as girls. Like a lot of girls are actually stronger than some.
I'm just making the case. I'm not saying this is true, right? Now, let's say, for example, we are looking at a circle, right? A circle. Let me draw a circle here, and we're gonna try to create a proportional relationship here, right?
That's not a circle. That is not a circle.
Right? What do you call this line in the circle?
It's an egg. Radius.
What do you call this line in the circle?
Circumference.
No, circumference. What do you call it? No, more than the radius. Diameter, right? This is the diameter.
That was a guess. You're not up here. He's trying to do me
Right? Diameter, right? This is diameter. So there's the circumference of a circle is proportional to its diameter, right? The circumference is proportional to the diameter. So we know that C, right, equals to something times D. We just need to figure out what is the proportional. What is the constant of proportionality? We need to figure out K, right? So basically, when I put C here, I mean the circumference is proportional to the diameter, right? There's a relationship between the circumference of a circle and its diameter, right? Now, I know by definition that circumference is equal to what? Pi times what? D. So this is C equals pi times D. Pi is what? 3.14, right?
When did
So-
we get into pi?
Well, I'm just giving you an
The
example.
circumference of a circle.
I don't
So,
know pi.
the circumference of a circle is what? Pi times D. So here, the constant of proportionality will be what? It will be pi because each circle that you take, any circle that you take anywhere, its circumference is always going to be what? The pi times what? The diameter. Everywhere you go, the circumference of a circle is always going to be pi times the diameter, right?
So cool.
Pi times the diameter. Everywhere you go, no matter what circle you take, it's always going to be circumference equals pi times the diameter. So this is called a proportional relationship, right? So this chapter here is just going to deal with proportional relationship or non-proportional. Now, if you have a relationship of this sort, let's say we have one third, right? 3/12, and let's say we have 4/16. Is this proportional?
Yes.
Is it proportional? Yes or no? Yeah, it's a question mark. 1/3. Is 1/3 equal to 3/12? No. So would this be proportional? Absolutely not, because they don't have this constant rate, right? Yeah. The only time you have a proportional relationship is if the rate in between the quantities is the same. If it's not constant, when I say constant, I mean if it's the same, then it's proportional. If it's not the same, it is non-proportional. All right? So this is pretty much it for this chapter. It's like this